Hello, Professor. Today I'm going to be doing shell method on lesson 7.3. So what is shell method? The shell method is finding the volume of a solid based on its revolution. Instead of using the disk and washer method, as we're slicing perpendicular to the x-axis, we're actually slicing parallel to the axis of rotation, depending whether it's x or y. And that's actually what creates the illusion of creating shells on a cylindrical shape. Now, what I have here written, I have the area of a cylindrical shape, which is 2 pi times the radius r and times h. However, when we're using the shell method, we're actually finding the volume, and therefore we have 2 pi times the radius times h times dx, or depends on where you're using it on dy. Excuse me. So dy and dx is actually supposed to measure the thickness, how it's constantly changing. For example, here I have the shape when it's vertically being cut is being cut downwards. Now, when it's horizontally being cut, the shape is being cut horizontally like this. So therefore, when I'm solving for the rotation of axis of the rotation of the x-axis, the equation is going to be from a to b, the integral from a to b, whatever those bounds may be, of 2 pi times the function, which is r of y, times y times dy. Or when it's the rotation of the y-axis, I'm sorry, it's going to be from the integral of a to b of 2 pi times the function, but it's in terms of x times dx times y. That's what the function means, whether it's in terms of y or if it's in terms of x. Now, for example, I have an example here when it's in terms of the y-axis. So right here, I'm trying to find the volume based on rotated around the y-axis. And right here, I have y equals 0, y equals x divided by 1 plus x squared. And my bounds I here have are x equals 0 and x plus 1. Now, when I write my equation and when I'm using the y-axis equation, I have right here 2 pi times 0 to 1 of x over 1 plus x squared. Now I'm just going to do u sub and solve my question. Let u equal 1 plus x squared, and du equals 2x dx, which therefore would give me half du equals x dx. So I actually have that here, so therefore I'm actually able to solve it. So I'm going to rewrite it again. So I have 2 pi to the point from 0 to 1 of x over x plus x squared. However, because I'm solving over the y-axis, I have actual x bounds. Therefore, I have to change my bounds. So I have u of 0, which is my denominator. U of 0 equals 1, and u of 1 actually equals 2. So you could see 1 plus 0 squared is 1, and 1 plus 1 squared is 2. When I'm rewriting it, I'm going to have 2 pi divided by 2 from 1 to 2 of 1 over u. Therefore, when I solve it, I'm actually going to have pi ln u from 1 to 2, which therefore would give me pi of ln 2 minus pi of ln 1 equals, and then I actually solved it and got 2.178 units to the third power. Now, my mouse isn't working. And now when I'm solving to the x-axis, this is another equation that I have of when you're solving to the x-axis. Y equals 1 minus x squared over 16, and my bounds I have here are -4, x, and 4. Now I'm gonna have to accept. However, like I said, it's y-axis. However, I have it in terms of y, even though I'm solving over the x-axis. Therefore, I write my equation in terms of x. So now I have y equals 1 minus x squared over 16, and therefore I'm rewriting now. I'm just gonna do simple algebra. Y minus 1 equals -x squared over 16. 16y minus 16, right? Because I multiply the 16 on the other side, and I have -x squared. So therefore, I just flip the things around so it doesn't look messy, and I have a square root of 16 minus 16y equals x. Therefore, now that is now my new equation because I'm doing it over terms of x-axis. And when I plot it, I see something and I notice something because actually, even though it shows right here that it's that I put it in positive, it's actually positive negative. So when I do the graph on one side from -4 to 0, it's going to be negative r, or my r would be 16 minus 16y, the square root of 16 minus 16y. On the other side, for example, from 0 to 4, that's actually positive. Therefore, my radius is positive. Now, it's hard to calculate a negative radius. Therefore, since both of them are on the same level, since both of them equal to each other, I'm going to just take, like I wrote here, I have there's two halves. Therefore, I'm going to take 1/2 and then multiply it by 2. So here I have, for example, and I also changed my bounds. So even though I have -4x from -4 to 4, I'm going to have to change it. I'm going to have to change my bounds. And when I put, for example, -4x squared or 4 squared into my equation, I'm going to have 1 minus 6. It's always going to be 16 over 16. Therefore, I'm going to have 1 minus 1, which is 0. So therefore, that's why I have from 0, and then what it actually, the highest point I could reach is 1. Therefore, I'm going to change my bounds and I'm going to multiply the second half. So 2 times 2 pi, like I have in the other equation, in my regular equation, from 0 to 1, not -4 to 4, because even though it's on my x-axis, I'm measuring only my y's. So I have from 0 to 1, and I'm going to have, again, my radius, which is 16 minus 16y, the square root of 16 minus 16y, times y over dy, and that's my thickness. That's how it's changed. That's the changing. And then I got that I approximately equals 64 pi over 15, which is ultimately 13.4 units to the power of 3. All right, thank you.